Good evening, everybody. Welcome to this evening. It's Escape Studios webinar with me, Mark Spevick. I'm the head of 3D and course leader here at Escape Studios, and I'm going to take you through tonight, particularly looking at Houdini and procedural modeling, whatever that kind of means these days. I mean, procedural modeling really is an approach to modeling rather than a framework. I mean, the framework in Houdini is procedural. That's what we mean by procedural modeling. Everything you do in Houdini essentially is procedural, but it's a whole way of thinking. What we try to do is work in a non-destructive way. So when I talk about procedural modeling, what I think of is a set of procedures or jobs that you'll do to get your end result. So you're probably thinking, well, I can do that in Maya and other software. Well, the difference is in Maya and other software, what you do is fairly destructive. If you model something, you'll sculpt it, you'll pull things around, you've got an end result. If you need to make a variation, you have to do that again from the beginning. It's kind of a destructive workflow. There are ways you can speed that up and use Maya's history to sort of, finesse stuff, but ultimately you've still got to do some hand work in there that's unique, and you'll have to repeat that again if you need to make variations. Whereas with a system like Houdini, you can work that way if you want. But when we say procedural modeling, what we're meaning is we're actually going to build a tool. We're going to build a machine that will make a model for us. So we design a system that will build the geometry for us. The advantage of that is once you've got that system, you can generate lots of variations very fast with it. You'll see what I mean from today's example. So the example I'm going to talk about today is, say, for example, you want to draw a track, you want to make a track for a game. But at this stage, we know that we want a track. We want some barriers going along the side of the track and some posts. The track might go up in the air, so we want to see some posts to the ground. But we don't know the design of the track. It could be a figure eight, it could be a loop, it could be much more of a squiggly shape, or we might have 50 levels in this game, and we want 50 different tracks. So if you were going to model those in Maya, it would take a while. You could, there are techniques you could use to speed you up. But in Houdini, we're going to build a system that basically you just plug a curve in and it generates a UV track for you at the end. So hopefully I'm going to demonstrate that by building it. And hopefully you'll get a better idea on how you would approach a problem like that in Houdini and how you can turn that into a useful tool. And obviously there's a big demand for lots of assets these days, and people that can design the tools to make those assets. And that's where sort of this idea of procedural modeling comes from. So we'll look at a simple example today. So I'm just going to share my screen with you here. So hopefully now you'll be able to see my Houdini session there. Now you will notice on the Zoom interface, there's a Q&A button and a chat button. It's much better if you type stuff in the Q&A button, because it's more likely that I'll see that and be able to answer it. And I'll try and leave a couple of minutes to answer stuff at the end about the courses and things. So we do teach Houdini on the course. We're an accredited trainer, and asset building and procedural modeling is a small part of that. Obviously, we teach all the effects and everything else. But Houdini is sort of the leading software for making these kind of assets and tools, and it's being adopted more and more in games and VFX all the time. So it's a really, really interesting thing to have a look at. So like I said before, the demand is that we want to build a track. We don't know the shape of it, but what we'll do is we'll use curves as a foundation for that. So the idea is we can generate lots of curves, and then the track will build the geometry for us, complete with UVs. So the first thing I'm going to want to do is create a curve. So I'm going to create a geometry node in Houdini. And let's call this track maker. So I'm going to assume people understand a bit about Houdini. This is not a sort of an entry level. This is kind of mid-level webinar. So you should understand Houdini and sort of about the nodes and things like that. This is more of an approach on how you would model something rather than working destructively. We're going to try and work on a very general case. So the first thing I'm going to do is I want to put a curve in there. So I'm going to want to look from the top view here. So I'm going to hit the space 2 to come to the top view, and we'll just make a curve node. And with my curve node, let's just zoom out a little. I'm going to draw sort of an interesting shape for the track here. Let's turn that into a NURBS and let's close it. Maybe that's a bit too interesting. Let's make it a bit more organic. There we go, something like this. So I've got a track that might have a bit of a shape like that kind of thing. It's quite arbitrary. Doesn't really matter too much. Let's just pull that out a bit more. Let's get rid of that one. Pull that one across, just to make that a bit more rounded. Something like this. Cool. So that could be anything ideally. And like I said before, I'm thinking of a tool. I'm going to make a tool that's going to be useful. So I'm going to make a couple of null nodes so that I know that between here, this is where the tool would operate. So I'm going to call this curve in. I like to give these nodes a color. I like green in and red for out. So we'll just pop another null at the end here, and we'll call this track out. So I have that at the end there. Let's just make sure that's an underscore. And I like to make these red. It's up to you. You don't need to use colors. So our whole system is going to go between these 2 points, really. And let me just save to make sure that, just in case it crashes, because computers do that kind of thing, funny enough. So we've got our curve in and our system that we're going to build. So the first thing I want to do is build the actual track element itself, the road part of it. Once I've got that, I can then build off the barriers because I know where the road is. And once I've got the barriers, I can build in posts at one point as well. But the track is the foundation of everything. So we're going to look at some of the techniques that we can use to do that with. So if I turn on here, this is point display. There's not many points here. And what Houdini does best, it just deals with points and attributes. So what we really want to do is use those points to our advantage. And one of the cool things we can do in Houdini is copy geometry to points. And there's a few nodes for doing that. There's a copy to points node, but there's also a Sweepstop. The Sweepstop will allow us to sweep one curve along the points of another. But we need a nice amount of points. So what I'm going to do is add what's called a resample node. Let's pop that in here. And you'll see instantly this resamples the curve and gives me sort of all the points that I want there. Nice bunch of points going all the way around. Now, I don't like using this method by curve length. I like specifying a particular number of segments. Now, let me just hide this. It's not displaying correctly. Let me just change the scene view. There we go. That's what we should be seeing. So you'll see the resampled it to 10 segments. If I increase those, I can get the fidelity back up again. So let's leave it at this kind of a number here, something like 50. That might be good. Now, if I am building a tool later on, which we must consider, the user might want to control the resolution of the track. They might want a low-res version or a high-res version. So this slider is something they want to use. So what I like to do is when I'm designing these things, I like to give them a color, the nodes a color, of where the parameters that I want to change the tool from. So this is to remind me which nodes I can control stuff from. So here we've got sort of the resolution for that. We'll build this into a tool in a moment when I have a few more of those. So I said I'm going to sweep something along each one of these points, and you can see they're going to be evenly spread now. So we need a cross section to do that with. So I'm going to start with a line. Let's have a look at this little line here. And we need to make sure this is going to copy correctly, and it's going to copy from the origin. And what I want to do is actually copy the center copy this to the main curve here using the center of the line here. So I'm going to lay it down on the x-axis by changing the direction to 100, because what Houdini does is it copies it with the z facing forwards. So this will be basically 90 degrees to the curve. That's why I've put it along the x-axis. And if I just move the origin back, then we can see it's centered. And you'll see this is -1/2. It's -1/2 the length. Now, the user might want to actually change the length. If they do, again, this is not centered. So I need half of this. So let's put -0.31. Now it's centered. So one of the nice things about Houdini is we can build a relationship between these numbers to automate this kind of behavior. And we can do that by right-clicking here in length and copy this parameter. And then in the origin, we can paste the relative reference. And this pastes a what we call the channel command, ch. And this will allow us to refer to another parameter. If I put my cursor over the word length, you'll see it says parameter is called dist. So this is referring to that distance parameter. So you can get that quickly by right-clicking copy parameter, and then up here, right-click paste relative reference. So we can multiply this by -1/2. And that will offset it to the center. Now look, the advantage of that is when I change the length, it always stays centered. So again, my user can change the width of the track and we know that it's going to copy correctly later on because we've fixed that behavior here. So again, I'm going to color this yellow because again, the user will want to change that. And then let's have a look at how that would work. So we can use what's called the Sweepstop to pull this together. So we put the backbone in and the cross section, and you'll see, there we go, it copies that curve from the center, from the origin, around the other bigger curve. And look, we can change the length, which is basically the width of our track. And here we can change the resolution and get a smoother or darker track. Now on the Sweepstop, it has another advantage. Here we can go to UVs and it will actually calculate the UVs for us. So if you turn on compute UVs, it's created them for us. If we do space 5, we can see that in the UV editor here. But we can also use a UV quick shade node to quickly preview how those UVs might look. And there we go. And we can see that they're mapping on nicely around our shape for us. They're following the curvature there. So again, if we increase the resolution, you'll see the UVs automatically generate for us. So this is really handy. And one of the nice things about Houdini is these attributes. If I middle click, you see we have this attribute for UV. These get passed down the pipeline. So everything we should do, at least to this track, will inherit that. So what else can we do with this? Well, let's go back to the line here. Excuse me. And let's turn on the points. We might want to change the cross section here. So let's have a look at that. Let's have a look at how we might want to change the cross section. So what I'm going to do is use another principle in Houdini called grouping. So let's use a group by range node for this. Let's turn this on. It highlights what it's selected. It's selecting the primitive. There is only one primitive, this curve, but I want to select points. So let's change this to points. And you'll see both points are highlighted yellow. Let's increase the resolution of this curve by adding a few more points. Let's add 4 points. We've got 2 in the middle here. Now this group by range is selecting all the points. That's why they're highlighted. But I can actually tell it to not include the first point and not include the last point. So it's only selecting the points in the middle here. And again, this is what we call procedural, meaning that we can actually change the number of points. And you see it's always making sure the endpoints are not selected. So again, you know, we can quite freely change stuff and it's not going to affect our tool later on. So let's call these this group here. What we're going to call it, let's call it the middle. Oh, middle. There we go. So we've selected those middle points as a group. If we middle click, we can see that here, middle 2. So the reason we use groups is if I pop a transform node in, for example, here in the transform node, if I move it, I move everything. But all nodes in Houdini have this group section at the top. So you can actually say, we'll only move the objects that are in this group. It's like a partitioning type thing. So now it's only going to move the things inside that group. So now it just moves those center points. And it doesn't matter how, if I change the resolution, those center points will always be in the group and they all get moved that amount. So this is very handy. We can now change the cross section of our track. If we preview the track, let me turn on the preview there. There we go. Now we can see our cross section. So if I just move the Y, we can just adjust that. And you see it updates all the way through. And we can further refine this a little bit. So again, the user might want to move that up and down. So let's mark that yellow. And then we want to do a poly bevel. So with a poly bevel, I can set this to points. And look, we can bevel the points a little bit, which will create rounded corners for us so that we can get a bit more resolution on the track and make it with rounded corners. We could change the divisions and add more resolution on those corners if we wanted. Something like this, which just gives us a better cross section. Well, it just gives us some control. So again, the user might want to do that. So I'll mark those 3 things like that. Let's just move this up a little bit so we can see that the tool begins at that point. So again, if we sweep that all the way through, turn on the sweep node, have a look at it when it's UVs, you'll see the cross section is exactly how we'd like to model it. So that's pretty much it for this track section. Let's put the track out there. So another nice thing I like to do is put a net box around everything here. And let's call this track. And we can give it a color. It's a good idea to give them dark colors so you can see your nodes easily. And we know that this bit's finished here, our track section. And we can pretty much plug in any curve we like, and that should hopefully work. So let's just pop in a circle. Let's make sure this is on the ZX plane. Make sure it's a, actually, let's leave it as a NURBS. And if I just plug that in now to this null, you'll see that generates the track for that. Oh, look, it's upside down. So let's just reverse the curve's direction. There we go. And now the track's the right way around. We could put something in that to fix that if we wanted to. But there you go, the curve runs all around there. And we can switch back to our own little track here. Now, there's one other thing we haven't considered. If I actually select a point on this curve that I drew, and I lift some points up, hopefully we can see that at the minute. Let's lift those up. What you'll see here is the track actually is not horizontal. It twists, it banks around the corner. It's a nice effect, but it's not quite what we want. We want this to be sort of parallel, really. And when we start to build the pavements and stuff, you know, they'll come off at these funny angles. We want those to be parallel as well. So I just want to fix that. So what we can do is create what's called an up vector. An up vector will tell this cross section here which way is up. So it'll be parallel, or rather it'll be perpendicular to that direction. So we just want to create that up vector. And we do that on the curve here that we're going to copy our things to, the points that we're going to copy the cross sections to. So what I'm going to do is create a point wrangle node to create this attribute. Let's have a look at the track while I do it. And it's very easy. It's called up and it's a vector. So we go v at up equals, and we can set a vector by typing set. And we just want 0, 1, 0, which faces up the y-axis. Now, when I hit enter, you'll see that the track flips slightly. And you'll see now that it's parallel to the floor. It's always parallel to the floor, is the bottom bit, which is more realistic to a real track there. So it's very easy to fix that when you're copying things to curves, is to give them an up vector here. In fact, if we'd set this to, instead of setting it manually here, we can actually type in CHV and call this up vector. What this will do, this will create a parameter that the user can then edit if we want to. It's gone funny because we haven't got a value in there. If I click this magic button though, it'll make the parameter for me here. And if I put 1 in the y, we get back to where we were. But the advantage of this is, look, if I change the up vector, I can actually rotate this around the curve because that's the direction it's facing in. So you can have it face along the x-axis. There you go, so it's trying to face along the x-axis. But here, up obviously makes sense. So up vectors are quite useful for doing that kind of thing. So now we're quite good. We can have the track going up in the air and coasting around, that kind of business. So the next thing I want to talk about is generating sort of either pavements or barriers. So what I like to do is break down my tools into these modular sections. Now, before we do that, let's actually turn this into an asset. So to do that, I'm going to create an output node. An output node is similar to a null. The only difference is whether or not this is visible, whether or not you turn this blue eye on, it always outputs this node. So it means you don't have to remember to turn it on if you're making a tool, which is quite useful because often I forget, and that can change the behavior of your tool. You'll see what I mean in a moment. So the tool belongs between these parts here. So I'm just going to select all these nodes. And to make a digital asset or a tool in Houdini, there's 2 steps. The first one is here. You've got to click on this cardboard box to make a subnet. There we go. And I like to give it the name of my asset now. So we'll call it, so WB, hang on a sec, WB track asset 2. Give it that name. And these inputs here are actually the name of this input here. If I hold my cursor over that, you'll see it says subnetwork input 1. That's actually what's here. What we want to do, we want this to be the curve in. So if I put my, oh, don't worry about that one. If I put my cursor over here now, look, you see it says curve in. So it gives the user a hint of what to do. Now to turn this into an asset, we right click and do create digital asset. This will be the name of the asset, WB track asset 2. And it opens up this window. And it's here that we can create these parameters for our asset. You'll notice there's no sliders or anything. So we're going to make sliders for those tools. So the first thing I want to do is make a section for track here. So we can use a folder and we'll call this track. There we go. And if I go up here, you'll see that the folder becomes a tab. So we want some of these parameters for our track tab. So the first thing I'm going to do is give them this resolution here. So we can right click and go export parameter to type properties here. And this will put the parameter for that. So let's call this res. That's the short bit you put for code. And this is the what the user reads, resolution. So I'm going to drop that in this track folder. If I hit apply and go up one, you'll see it's now put this resolution in the folder. And look, I can actually control the resolution from here. And you'll see inside this is now linked automatically. That you need to do it through this interface when you're building your assets. So here I can actually now start to build up the buttons, the important settings from here at the higher level. So at this level, so only the user can access the bits that are important. Next thing I want to do is give them the width of this line here. So we can actually hold down Alt and middle click on the parameter we want, and you'll see it jumps across to this window for us. So we'll call this the width, because this is the width of the track. Let's hit apply. So again, if I go up one, I can test that. There's the width here. So we can see, yep, that controls the width. Let's go back inside and promote some more. So here, I'm just going to promote this Y translate. So we'll call this, what should we call this? Let's call this depth. So then the user can pull that up and down, the depth. And then on the bevel here, what we'll do is we'll give them this distance. So if you look, oh, where's the bevel? So if we do that, we can kind of soften the edges. What else can we do with that? We can do the divisions. We'll leave the divisions down low and just let them control the distance here. So we'll call this soften or something. You can give it better names if you want. Soften. Soften, there we go. Let's hit apply. So if we come up one now, we have all these parameters so that we can change the depth, push that up and down. We can soften it here. We can change the width of the track, and we can change the resolution of the track as well. So we've promoted all those interesting parameters from inside here and given the user those controls. So slowly we build up our little tool. So again, I'm going to make another null now. We're going to talk about making the pavement or the barriers. I'm going to call this barriers, because I'm just going to go for barriers. We can always build in extra behaviors later. So we'll call that barriers in. So again, I like to color these a green color. So from the barriers, what I want to do is actually, I'm going to build them off again by copying to points or sweeping. And I'm going to want these sort of points at the edge here. I don't want this inner geometry. I want this outer curve and this outer curve, so I can build geometry from those. So when we can do that with a split node. If you remember before, on the cross section, I selected the points in the center here. That attribute has been carried through. If I have a look on this information, you'll see that these middle points have been carried through. There's 932 now because they're all on this outer edge. With a split node, we can actually choose that group. And if I invert the selection, you'll see it's just kept the points that are in that group, which is this outer edge, which is really handy because that's actually what I want to use to generate the other bits that I need. But I need to generate some data on these, so basically a direction on them, and for that I need some geometry. So what I want to do is actually turn these points back into curves, and for that I'm going to use an add node. So the add node is very, very cool. You can actually go to polygons by group, and you'll see it joins everything up based on an attribute. It's doing the point number, so it's doing point 0 to 1 to 2 to 3, which zigzags like this. I don't want to do that actually. What I want to do is actually separate them into each separate curve. Now, again, if we go back to our cross section, let's go all the way back to the cross section here. Let's turn on the point numbers. This is what we're copying through. Now, remember I said the attributes get copied through the sweep and everything else. What I want to do is give each point a unique attribute. So when I copy them later on, the whole line of points will have the same value, and the add can use that to join them up. And if we look at the point numbers here, they're fairly unique. So I'm going to use that. So I'm just going to create a point wrangle just after this, and I'm going to steal this point number. I'm going to use an attribute. So let's do integer at ID. Let's call it ID. It can be anything you want. And then I at PT num, which is the current point number. So if we come down to the sweep now, here, what we can do is visualize that point number. Should be able to click on ID here, that ID. There you go, that visualizer is now showing it up in color. Let's edit that visualizer. So let's do this as a marker. Let's turn off the point number. And you'll see each row has the number of the original point that made it. This is 0, 1, 1, 2, 2, because these came from the same point. We beveled it. And there's a 3. But they're all unique. That's the important bit. So if I go to my add stop here, I can say, let's do this by an attribute, and let's do it by the ID attribute. That's actually coming all the way through. There's our ID. There's our ID. So yeah, there's all zeros, those are all ones, and there's the add. Not doing its thing. So yeah. Don't know why that's not behaving itself. I think that's not drawing properly, to be fair. So yeah, if we click close, we can close the shape. So it's drawing that properly now. And you'll see that we've got our two curves. Let me turn that visualizer off. There we go. You can see we've got our two curves going around the geometry here. Let's turn off the that bit. So they follow around. So what we don't want to do, we don't want this closed, so we can use an ends node to actually open it up into just the two curves that we want. So we can set this to unroll with new points, and you'll see now that we've got our two curves running around our geometry there, which is exactly what we want. And then what I'm going to do is I'm going to copy or use these as the foundation of the barriers by copying geometry to them. And again, we can change the cross. The reason I'm doing it like this rather than extruding it is so we can change the cross section again using the same method we built for the track. So I'm just going to middle click. We've got 468 points. Often this doesn't close properly. We're kind of fusing a gap. So I'm just going to create a fuse point just to make a fuse node to make sure we're merging any vertices that are on top of each other. If I have a look now, you see we've got 466, and before that we've got 468. So we've merged two vertices. So these are definitely closed now. So I just wanted to make sure that that was happening. So what I'm going to do now is create an assemble node. This will create groups based on the separated geometry. So if I turn on create groups and call these curve, you'll see I now have two groups, one for curve 0 and one for curve 1. So I can separate these two curves out, again using groups. And then we'll use our split node to split that up. So if you put one of the curves here, that's what you'll get out one input, and out the other output, you'll get the other curve, or the other, what's not in this group, essentially. So let's create a cross section for that. So let's make a line again. And remember how I said the line gets copied from the origin here. Let's put that along the X again. But this time I'm going to leave it with the point at the origin because I want it to copy out from the curve, not from the center, because my track goes in, if you like, the track would come down here and this would come out to make the pavement. So again, let's make that quite short. And let's color that yellow because they might want to change the length of that. And if we just pop in our sweep, we can see what's going on. Let's pop that into this first input there. You can see our point is getting copied to our sweep there. So that's not really working as we expect because it's being rotated. Again, we need the up angle, so that up vector. So if you remember, I made this pointer angle up here. Let me just copy that one. And we'll just paste it up here so it gets copied into both curves. And there you can see that that's getting copied parallel to the floor again because we popped in our up vector. So again, we can create UVs for this pavement by turning on UVs in our Sweepstop, the advantage of using the Sweepstop. And if I just template the original track, where is it? There it is. So there's the original track. Let's just template the sweep. We'll see that that's gone very, very large for us. Let me just bring the length down. Now you'll see it's actually gone the wrong way. It's going over our track. That's not actually what we want. Let's just pop a transform node in, and we can flip this 180 degrees over. Oops, sorry, now I want to flip the line here actually. So we'll flip the line here 180 degrees. So it goes around the other side. There we go. So now that's attaching on one side like I wanted. The problem with doing that, it's reversed. But here we can just simply reverse this cross section so it's the right way round. Obviously, I want to repeat this process on this other branch. So let me just make a copy of this sweep and plug the other branch in. Now this other branch, we don't need it flipped. Let me just not have the transform going in there. So that now we have both bits of track here, pavement, and we have the track in the middle. And they're all joined off each other. If I come back to the original curve, which is all the way out here, oh, hang on, we can't see everything. Let's just see if we can see everything together. So what we can do is add a merge node. We can just merge both these together. So we'll see both tracks here. And then what we can do is just bring this down there, add another merge node with our track. And let's just merge in this as well. So now we can see everything together. There we go. You can see the track with the barriers. If I click my curve, you'll see again, as we change this, everything updates and it keeps that modeling as we want. So this tool is quite getting much more robust now. So a little thing I might want to do actually is turn these into actual barriers. So again, let's do a poly extrude node. And we can do this after we've merged them all together. Let's turn this back on. So the extrude, if we say individual elements, we can inset them in a little bit to create these kind of little shapes like this. And if I turn off the sides, you'll see we get these little inset blocks. So they can control the gap between them. So again, the user might want to control that. So again, with another poly extrude, we can take those little blocks and pull those up. Again, this doesn't create the under geometry. If you want that, you can turn on output back. There we go. So we've created little boxes for those. And we could do a poly bevel actually. So they might want to create some softer edges on there. So we're going to do a little bevel. There we go, something like that. And then we can do a UV unwrap just to create some nice UVs on those. And if we pop in a quick shade, we can just quickly see what we've got. So let me pop that into this merge so we can see everything with the quick shade turned on. There we go. So the problem with the UV unwrap, let me just color these yellow, is that we're unwrapping, we're projecting onto this whole shape. I want to project on one cube at a time. So we could quickly put in a for each loop in Houdini. So I'm going to do this for each connected piece. So this will work out which pieces are connected to each other, basically each individual block. And then this will just do the UVs for each individual block one at a time, rather than the whole lot all together. So if I just change that now, you'll see we loop through each one and we get much better UVs per cube. In fact, they're all the same. So we just need to map one of them. So again, we've created our little barriers here and we've got lots of control for that. So again, we could just run this into a little net box, call that barriers. And then let's just give that a color. And then let's promote some of these parameters. So let's create another folder here. Let's call this barriers. And let's promote some of these parameters. So this would be width of the barrier. Remember, that was the line length. And then here we have the inset. So we'll call this gaps. So it's the gaps between the barriers. And then this was the height. So we'll call this the height. And then this was the bevel. So in fact, we could add another folder in there and then put these inside that folder. Let's call this bevel, that folder, and then we've got the offset. So if we go up one now, we'll see that we have our barriers now. And look, there's a tab inside for the bevel. So again, up here, we can adjust the width of those. We can adjust the gaps between them. We can adjust the height of them. We can adjust the distance of the bevel and the quality of the bevel with higher rounding or less rounding subdivisions. Oh, it's a bit slow. Don't want to do too many. So there we go. We've got lots of extra control at the top there. So let's put our little null at the end so we know that we're finished with that. And we'll call this barriers out. So, and I like to give that red color, don't I? Cool. So we've got those barriers. So the last thing I want to do is create some posts that go to the floor here. So what I'm going to do is come back up to this merge. Do you remember the merge? This is where those original bits of track were. I want this geometry for a particular reason. So I'm going to pull out a null at this point again. So I know that my next bit starts here. So we'll call this posts. Again, I like to make that a green. So again, we're going to split that off into the two curves. Because we've kept our groups, that should be easy. So we should have curve 0 here, and then curve 1 coming out the other output here. And what I'm going to do is I'm going to create a polyframe node. Now, there's a reason I want to do this, which will come clear in a moment. If I turn on the polyframe node, it calculates the normals here, which are just going straight up, or based on the curvature of the geometry. I don't want to do that. What I want to do actually is calculate the tangents. If I put an n here, you'll see I'm calling the tangents the n tangent. And what I'm trying to do is basically the point on this outer edge again. I want the outer edge points. I want that to be straight outwards. Let's set this to first edge. And you'll see they're a little large. If we tap D for the display here, we can change down our guide length, scale the normals right down so we can see those in there. There we go. And what you can see is these points now are facing 90 degrees to the plane there. The reason I did that is to put in a peak SOP. If I do a peak SOP here, let's not recompute the normals. If we do that, it pushes them in the direction of the normals, and you'll see that can push it out or inwards. So now I can move the posts 90 degrees to the track in and out. So this gives me the sort of the depth or distance for the posts a bit. You'll notice this is a negative number there. Let's do the polyframe for the other one. So let's plug this into the other one here. And you'll see this is on the wrong corner. I need it on this outer edge. So I'm going to do that as the bitangent here. If I turn this on and call that N, there we go. You see that's on the edge that I want it to be now. And this peak will actually be in a positive number because it goes in the direction of the normal. So that wants to be a positive number, this one. So what we can see is these two peaks actually want to be the same number, just one negative. So I'm going to let the user control the positive one. So we'll copy this parameter. And on the peak here, we'll paste relative reference. So now, let me just template this one as well. So if I just change this value, you'll see that we radiate out the way that we want. Let me just merge those two together. Just make sure that's working. So is that one working? So we've got our original track there. That one's there. So that peak. Oh, yeah, sorry, this wants to be times -1, so it's negative. That's what I was forgetting to do. So now that one will push outwards. There we go. Let's turn off the normals. So if we adjust this peak here, you'll see they push closer and further away from their original position. So 0 was the original position. Then we can just push those further out. So I'm going to keep them in their groups. What I want to do now is get rid of the endpoint. Now, if we go back to our cross section, which was, where was that? That was here, this line. If we go back to this cross section of the barriers, remember, I'm copying this point to the original curve, and this is the outer edge. I want to keep this outer edge, so I'm going to make a group for that. Let's make sure that both of these nodes connections are going in there. We'll call this end, and this is the a point. Oh, hang on, I've pressed caps, end. Oh, I can't spell it. There we go. I want to make sure this is a point. And what I'm going to do is, oh, so I want to group by range, actually. Wrong one. So group by range. Let's just pop that in. There we go, got our points. We'll call this end because it's a single point here. And we're going to not select the end one. So we're going to keep that one, which we'll get rid of, and then we'll keep those at the end. So if we come back to here, if I pop this blast in, and we choose that endpoint, and we say delete non-selected, so it will keep the outer one. You see it's kept the outer one for us on the track. And again, we can do this on the other one. So if we look at our original geometries there. Actually, then we're going to do it the other way around. We want to keep the outer one. There we go. So we're keeping the outer one here. And if I adjust the peak now, you'll see that point can go in and out 90 degrees. And this is what I'm going to copy my posts to. So again, I'm going to use a group by range again, because I might not want all the posts everywhere. So in this group by range, I'm going to call this delete me. And we'll set this again to points. And you'll see it's selected every point. But down here, we can go select every, say, 3 of 4. So we're selecting every 3 or 4, leaving every 5th, which is what we want to do. We want to delete these yellow ones so that we could delete every 2 of 3, which again leaves single ones. So there's a relationship here. So I'm going to take this copy parameter and paste relative reference here, and then add 1. So we're always selecting 2 of 3 or 3 of 4. And I can increase that, and it's the blue ones we're going to keep. So I can filter down. So again, we'll give the user control of that. So we can filter down the parameters that we want. Now, I want to do the same on the other branch. Now, instead of doing the check expression, we can also right-click, go to Actions, and create a reference copy. This will create a copy of that node. Oh, there we go. But with all everything connected for you, look, it's got all the expressions in there. So they're identical. So if I now, that's going to make our groups for us. If we now create a blast node, and I say delete me, there you go. You see, we just keep the ones that we weren't in the group here. So as I bring this number down, we can have it all the way back to all of them, or just filter them off. But we've got them evenly spread, which is what we want. Next thing I need to do is copy my tube to that. So let's create a tube for our posts. So guys, that's a little on the large side. So let's bring the radius scale down and the height down. So again, this might be something the user might want to do. So let's create a polygon. Let's create some end caps. And I'm actually going to light down the Z-axis, because it uses the Z-axis again to copy, and it will do it from the origin. So what I want to do is offset it so that this end 0 on the Z. So for that, I can use a match size node. So the match size, you can do all sorts of repositioning here. I'm going to move the Z-axis to the minimum of the bounding box. There you go. So you'll see this points off in the positive Z, because that affects how it will copy when I use the copy to points node. So if I now use the copy to points node, you'll see it copies them all the way down there. What we need to do is create a polyframe node, I believe. Yep. Oh, yeah, no, that's right. I want to set the Z upwards. Let's do this on the Y-axis, and let's set this to no center, and justify that to minimum. There we go, on the Y-axis. So this gets it sitting bolt upright on the Y-axis. So we build it on the Y, the match size offsets it to the Y bounding box, and then we copy that to our curve there. And you'll see it's facing up 90 degrees as we go all the way around. Oh, we've got a couple of funny ones there. So let's create an up vector again. put that on our original curve, because again, the copy uses that. So we'll say v at up equals set 0, 1, 0. There we go. Let's fix that a little bit. There's my group by range. Oh, let's plug our blast in. There we go. That fixes it. Forgot to wire the blast in. So there we go. So now we're just copying our points to there. And we can adjust the height here. We can give the user access to that. So we've got the height of this. Da, 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 da. So the last thing I want to do actually is I just want to grab these bottom points here. So for that, I'm going to use another group node. And again, we'll grab these points. We'll call this bottom. So we'll turn on bounding regions. And you see we get a bounding box. So I'm going to shrink that right down. So it's just around these bottom points here. And then what we'll do is we'll add a transform node after the copy. Oh, sorry, not a transform node, a wrangle node. So in the wrangle node, I can tell everything's at p.y. Everything's positioned in y to be 0. In other words, all hit the ground. And what you'll see, it's flattened all the points of those tubes to the ground. But if I say just do it on that group of the bottom points here, you'll see it just pulls the bottom points to the ground, regardless of where the track is. Let's lift the track up a little bit. Let's go back up to our original up here. So let's just pull the track off the ground a little. As you'll see it there, it will then generate all the points to the floor for us. There we go. So now we've got our posts with a fixed height above. So here I can adjust the height above, but they always go to the ground to ground our thing in there. So again, let's make a null for this. Call this posts. Let's color them red. And what I like to do is create groups for these things so we can use that later on. So we'll call this group posts. And we'll just copy that group node, paste one over here, call this barriers. Well, let's put that up there. So barriers, and then the last one for the track. So we'll put this one up here. We'll call this track. It's always good to have groups in Houdini. So this last little lot here, if we just tidy those nodes up, create a net box. We'll call this posts. Give it a funky color, just to make everything the same as before. And again, oh, we want some UVs on our posts. We'll do a UV unwrap. Just pop that on our single tube so that gets carried through all of them. We can merge that in. And look, we can see with our quick shade, there's all our posts and everything all building all as we want. And again, if we come up here and just change that curve, you'll see everything is just generated. It took me a little while to build the system, but now I can just plug in a curve. I could plug in a circle. And it's just going to build my track for me. And I could plug in any kind of curve and make suddenly lots and lots of UV'd tracks very, very easily. So last but not least, let's just promote up these setting parameters here for the user. So again, let's make another folder. Let's drag that up to the root so it is not inside the others. So let's call this posts. So here's the peaks. We'll call this offset. So obviously the names can be whatever makes sense to you or your user. So here we'll call this post prune, because we're kind of pruning the numbers off. Post prune. Where we? Oh, you go. There's the post settings. So actually, let's make another folder for that and call this post settings. Make sure that's inside the other post group. And then on the here, we can give it the radius, height, and scale. And we could promote other ones like the resolution if we wanted. I'm not going to do that for now. Is there anything else that we needed here? Not really. I think that was it. And remember, we're always outputting this output node. So if I think that in there, we'll see we're now outputting with the UVs. So we'll leave that off for the minute. Leave the output out there. So there we go. So now I've built my tool. So the useful thing is this has become what we call an asset. So if I hit tab, you'll see in assets there, you'll see my tool appears, and I can plug in another version. And I've got two kind of tracks. If I just merge them together so we can see them at the same time. So let's just pull that one over there. Oh, that's not a merge node. There we go. And then I can just keep plugging in lots of different curves, and I can generate lovely lots of UV'd geometry very, very fast. So now, you know, in the space of an hour, I built a tool, and then in the next 20 minutes, I could generate, you know, 50 different tracks. Whereas if I was trying to try and do this in Maya, even with all the wonderful tools in there, it would take you a time to sort of obviously model all this by hand. Oops, sorry, Ella, I've just seen your question there. What does the blast node do? The blast node is the same as a delete node, just without half the buttons. You blast away the geometry. So it's a delete node without a lot of the settings to keep things simple. So one last little demo I just want to show is once you've now built this tool, you can use it in your other DCCs, for example, something like Maya here. So that I can actually load that asset in Maya. There's the asset I just made. Here's some curves already drawn in Maya. And again, look, we can just set to selection, and there's my track in Maya. And look, we've got the settings here. Those tabs become these folders. Look, there's my posts and barriers and track. And look, I could change the resolution, can change the width of the track. We can change the depth. Remember that pushed the cross section down. We've got the soften, change the width of the barriers, the gaps between them, can make them higher and slower. And look, the same with Maya, same with Houdini, as in Houdini. Look, we can reload this another instance of that asset in. And again, if I load that in, we got that. Oh, wrong curve. I actually want this other curve. There we go, set to selection. There we go. Now we generate that around that other curve. And we can just pull things around, and you'll see it just generates fine in Maya too. And this will work in Unreal and 3ds Max as well. So it's very, very handy to build these tools. And the foundation is that what we call this procedural modeling. And essentially what that is was building in all these behaviors, linking the things that I needed to together here, building things off other things so everything's interdependent. You saw using the chat expression and making copies of the same node, all to make sure everything was coming through the pipeline in this kind of procedural manner. So you can literally just plug a curve in and the tool does everything else. You just got a few sliders to change what you're doing. And it's quite fun designing these systems. It's obviously a little more effort than just modeling it. So I would say if you were just modeling one track or even two, it might not be worth building the system. But if you know you've got to model 50 or 100, it's certainly worth building the system, because then you can kind of automate it and let it go. And then you can reuse this again and again or modify it. As you saw, we could add lots of other features quite easily to the track, other details. We could build that into that tool. And it really is that flexible. And the fun is, as you saw, you can run it in other software very, very easily, like Maya. The other advantage, what I did, the reason I made those groups is, look, those groups come through in Maya. Look, there's my barriers group. So if I just select the set members, there we go. I can shade and apply shaders now in Maya to those geometries. So let's go back to face, and let's assign a new material, for example. So it's easy, you can access to do your shading in Maya. So look, there's all the barriers. So here I can grab the track here. So select set members. Let's make sure we're in face mode. Oh, don't want to select the CVs there, face mode. And then here we're going to do face mode as well. Just make sure we've got both bits of geometry. See, it makes the actual geometry here for you. So it's probably because we've got two instances of it there. Select set members. So face, there we go. So assign a new material. Let's give it a different one. Let's give it a yellow color. There we go. So we can apply different shaders to the parts because the groups came through from Houdini here. Excellent. So hopefully that's given you, I did cover quite a lot in this in this demo. I did want to sort of show how fairly quick it is to sort of build a system. That's not true, actually. It took me a while and a few problems to sort out when I built this system. But, it's quite easily done. You always hit issues as you go along. But you can see the structure there. Start with something basic like a curve. I've got one system that builds the track, another that builds the next bit, something else that feeds off that. So everything is linked to everything else. And that's kind of what we mean by procedural modeling, I think, at least, is building these sort of agnostic systems that you can just plug in, whichever, type of curve you want and do the rest. And you could build settings in here so the user could plug in their own geometry for the posts or their own geometry for these barriers rather than the tool creating it. But that's up to your imagination, really. So hopefully that's given people an idea on procedural modeling in Houdini and how you can generate lots of variations of something quite complex very, very fast once you build a system. And that's what procedural modeling is. You're building a system. You're not actually building the geometry. You're building a system to build the geometry, a machine, which when it's reused is incredibly powerful.